Section 4.5 is all about rational functions. A rational function is just a polynomial over a polynomial. So what's going to happen is we're going to give you something that looks like this, and you're going to be able to give us something that looks like this nice little graph, the vertical asymptotes, a horizontal asymptote, x and y intercepts, and a domain. This tends to be one of the more problematic sections, and it's usually, if there are problems, because people look at this, then plug it into their calculator and try to get all this out, and that's going to cause you problems. What you need to do is take it step by step, and there are the steps. There's only 5 of them, and if you just follow these steps kind of blindly and just go through them and then graph, it's going to be a lot simpler. So the first step is simplify, which basically means factor and cancel anything that's similar on top and bottom. Vertical asymptotes, where the denominator is 0 in simplified form, which is a little bit different from the domain. And let me show you what I mean by that. So here I have a perfectly good rational function, and I'll try and simplify it. And when I look at this, these two terms will cancel. And that focus is not working today, is it? So, if I look at this, the domain comes from the unsimplified form. So the domain is coming from this original equation. So in this case, for the domain, I'm going to eliminate -2 and 2 and write it like this. But the asymptotes come from the simplified form, which is this. So this equation only has one vertical asymptote, and that's at x equals -2. And we'll see what that looks like a little bit later. Next we have horizontal and oblique asymptotes, and there's a whole list of rules for those, which we'll go into in a little bit. And then the x and y intercepts. For the x-intercept, all you're going to do is ignore the denominator, look at the numerator, and see where that's 0, and that's going to be your x-intercept. And for the y-intercept, you're going to plug 0 in for x and see what you get out, and that will be your y-intercept. And like in that first example I showed you, they might be in exactly the same place. Now, here are the rules for horizontal asymptotes, and they can get a little bit confusing. So let's go through them one by one. First one, if the degree of the numerator is less than the degree of the denominator, then we have a horizontal asymptote of y equals 0. And what that means is equations like this. Degree in the numerator is 1, degree in the denominator is 2. Degree in denominator is greater, so y equals 0 is our horizontal asymptote. Second rule, if the degree of the numerator is equal to the degree of denominator, we get leading coefficient over leading coefficient. So, in this particular example, both numerator and denominator are degree 2. So I just take the leading coefficient over the leading coefficient, and the line y equals 2/3 is my horizontal asymptote. Next, if the degree of the numerator is greater than the degree of the denominator, we have no horizontal asymptote. So in that case, there would be no horizontal asymptote. However, if the degree in the numerator is 1 greater than degree of denominator, I have something called an oblique asymptote. And we'll get into that a little bit later, and I'll show you how to do those. But for now, let's just see what kind of horizontal asymptotes we have with a few equations. So looking at this one, degree in numerator is 1, degree in denominator is 2. So degree in denominator is greater, so y equals 0 is my horizontal asymptote. In the second one, degree of both numerator and denominator is 2, so it's going to be leading coefficient over leading coefficient. And in the last one, degree of numerator is 2, degree of denominator is 0, so we don't have any horizontal asymptote. And now let's do one of these oblique asymptotes. On this one, degree of the numerator is 3, degree of denominator is 2, so we will have a horizontal an oblique asymptote. What we do for oblique asymptotes is set up a division. Sometimes synthetic division will work, sometimes it will not. So in this case, we're going to have to do long division. So I need to multiply this by 5x to turn it into this, and then I just go through and multiply this entire polynomial by 5x. Let's see, that's negative 80x. And I like to change the signs on these rather than subtracting because it helps me to not confuse pluses and minuses. Let's see, these cancel. And already I'm done because I can't bring down the same number of terms as I have here, and the degree here is less than the degree here. So what I have is 5x with a remainder of 80x. For oblique asymptotes, you throw out the remainder. We don't care about the remainder for oblique asymptotes. We just care about the quotient. So the oblique asymptote here is just 5x. So now let's actually work through one and graph it. Alright, so given this, first step is to simplify, which basically means factoring the denominator in this case. And nothing cancels. So what I would get to start off with is a vertical asymptote at 3. I'll just draw that in and label it. And one at negative 3. And since I didn't cancel anything, the domain is going to exclude both of those points. So negative infinity to negative 3 unioned with negative 3 to 3 unioned with 3 to infinity. Let's see, next comes the horizontal asymptote. Degree on the top is 1, degree on the bottom is 2, so y equals 0 is my horizontal asymptote. Next are my x and y intercepts. For my x-intercept, just look at that 2x and figure out where it's 0. And it's 0 at 0, so my x-intercept is 0, 0. And if you have something going through 0, 0, the x and the y-intercepts are going to be the same. But let's just do the y-intercept to make sure you know how it works. For the y-intercept, just plug in 0 for x. And when you work that out, that again gives you a 0. So they are in fact the same place. And we've done everything we can algebraically. Now we just plug it into the calculator. And when you do that, you're going to see something that looks kind of like this. And your job now is to take this picture you have here and fit it inside this framework. If you get this picture first and then try and get the framework, you're going to get into trouble. So build your framework first, then go back and take the picture and put it inside the framework. So we have this little branch here in between the asymptotes. Then another branch here going from the asymptotes through my intercepts and then down. And then another branch up here, again going out toward the asymptotes. And we're done. We've successfully graphed that rational equation.